waiting for Bhushan, but I'll go ahead and do an intro. Like, I can't tell you guys how excited we are to have you all here today. This is the first event of this particular nature that we've held, and so it's really exciting. It's awesome to see it all come together. So I want to tell you who we guys are, who we are. If you guys haven't heard of Madrona Venture Group before, although obviously you would have heard it from the email when I reached out, but basically we are a seed stage venture capital firm. We focus our investment here in the Pacific Northwest, and it's primarily software startups, a little bit of hardware, but mostly software. We've been around for about 20 years now, and we've been involved in some of the biggest sort of success stories, software startups in the region. So pretty amazing firm, and hopefully you'll get to know us a little bit better, and we'd love to get to know all of you better. So that comes to what this is all about. Had a couple questions about that, and essentially, we've had hundreds of conversations, maybe thousands over the past couple of years with technical people, and a lot of times when we talk with folks like yourselves, you don't know what we're up to, you don't know what's going on in the startup scene, and we really think we need to address that. The technical community here is really important to us, and really important to our companies as well, who are building pretty amazing stuff, and we want to sort of foster the community and be more deeply and more broadly integrated. So it's about raising awareness and making you guys excited, or helping you guys get excited about all the exciting stuff that's going on in our backyard. So yeah, without belaboring it too much more, we'll go ahead and get started with the stuff that you guys are interested in. So what I'll do is go ahead and give everyone on the panel a chance to introduce themselves. And aside from personal introduction, if you guys could give like a one-line or a couple-line comment on what your business is and why your customers need or love you. And so also one little challenge is that we have a couple companies in stealth mode. So there's a little bit of sensitivity. We'll try and work with that as best we can.
Hi, my name is Bhushan Khanal. I am a Director of Engineering at ExtraHop Networks. ExtraHop Networks, what we do is we build a platform that does real-time wire data analytics. Effectively what this means is we allow large IT operations across a wide area of verticals to give real-time metrics on their performance for their systems. And we have most of our customers are Fortune 500 companies.
My name is Kiran Bhageshupur. I'm the CEO at Igneous Systems. I'd love to tell you what we do, and I'd be happy to do that under NDA as soon as you guys will come to chat with us. But we're very early stage. In fact, for about 7 months, we spent time right here in these cubes here as Madrona incubated us in the beginning of this year. So we are less than a year old. We are less than 20 people. And we're really looking at some things which are pretty radically different than what exists out there, either in sort of the cloud or in the enterprise data centers. I can't tell you why our customers will love us because we don't have any yet, but everyone that we have talked to have gotten pretty jazzed about what we're doing, and usually it ends with, so when are you going to actually have a product to sell us? So.
Yeah, that last question is a rough one. So, my name is Benn Bolay. I am the CTO of Union Bay Networks. We are 1 year old. We were here in Madrona for a couple months and then moved to a very nice office above Yak Teriyaki in Fremont. So we're about 9 people large, but we're growing really aggressively right now. We are plugging the infrastructure gap for cloud applications. As enterprise companies move into the cloud, they find a bunch of empty space underneath them that networking solutions, load balancers, firewalls, NAS, understanding all those pieces, all that's very difficult to do. So we're providing software to help in that space and to solve networking problems for them, especially from our F5 heritage.
Great. My name is Peter Godman. I'm CEO of Qumulo and one of the 3 founders of Qumulo. Qumulo is a company that builds a product that helps people store, manage, and curate hundreds of millions to hundreds of billions of digital assets. And being in stealth mode, that's kind of what I can say. I can tell you that we are at the stage now, we've been in business for about 2.5 years. We're at the stage now we have first customers, so exciting times. I'm not a stickler about the NDAs. They're a little bit further along, but I'm kind of a pushover. Just come talk to me and I'll tell you more about what we do.
I'm Aaron Passey, the CTO at Qumulo. Pete has said the rest.
All right, thanks, guys. So since there's a little bit of sense of...
Who are you?
So my name is Hoken. I'm part of the talent team here at Madrona, and a lot of what we do is community outreach as well. And I've been here for about 1.5 years. My background is online development, Microsoft for a large number of years, startup before that, and then school before that. And that's it. I think a lot of you kind of know me. I'm sure you see my LinkedIn profile, but if you want to know more about me, happy to talk. And of course, you can always talk to me about Madrona or anything else that you're interested in. So yeah, with the sensitivity around the products that you guys are building, maybe we can talk a little bit about some of the technologies you guys are using, if that's not too sensitive. And of course, starting with Bhushan, which a lot of what you guys are doing is already enhanced customers and so forth.
Yeah.
Maybe that'll sort of grease the wheels a little bit. But yeah, what are some of the core technologies that you're working with in solving some of the stuff that you're working on?
Sure. I think that it's mostly around networking is probably the singular core. I mean, we built basically a networking microkernel that does high-speed packet processing. So, and not only does it can process packet, but it's also application aware. So we can process 20 gigabits, 40 gigabits of data, and basically collect metrics on it. And we've also had to build a pretty efficient storage to be able to store that data at scale and take it all the way out to the users to visualize it, to make that information actionable. So it is truly a full stack from packet acquisition to basically HTML UI to visualize it and allow people to basically process that information.
And has a lot of that had to be proprietary, or are you able to work with open source stuff, pre-existing?
We leverage a lot of open source, and when appropriate, we try to return it back to the community as well. But most of our IP has been built in-house because this is something that is very difficult to do in open source in that way. And then, like I said, we do try to return much of the technology that we feel is appropriate.
And have you seen shortcomings on open source, just not performance enough for what you guys need, or not domain specific enough? Or?
I mean, it's hard to, in an open source community, it's hard to be able to kind of bake your technology. For example, we have customers like Home Depot. They have 2,200 stores, and they monitor every single transaction over the ExtraHop. Expedia is another customer of ours that they're looking at their online booking. Morgan Stanley. I mean, these are scales that are well beyond what you can sort of create at your smaller enterprises. So just because of that, we've had to really build our IP around that, and we're using sort of off-the-shelf hardware. And we're not in the business of building hardware. So a combination of those are some of those problems present unique solutions that are difficult to kind of run into without encountering this in the wild.
So let me skip over to Ben, and then we'll come back to Kiran. But since you guys are doing stuff related to networking.
Sure. So for those of you who don't know, Bhushan and I both worked together at F5 Networks 2007, 2006, something like that. It's a long time ago. So we both come from a very common heritage there. So our platform is also very networking centric because we're trying to solve networking and connectivity problems for applications. So we look at it from the cloud perspective. So the technology stacks that we choose have to scale horizontally. We're not looking at building appliances or single pieces that have a lot of horsepower at that point, which is very much the F5 model. But we're looking at building something that, as application developers who are using public cloud resources scale horizontally as they auto-scale up and consume more or less resources based off of load, so too do the way we interact with the application and services we provide scale horizontally. So from our perspective, we're taking a look at a lot of, it's actually a really compelling time because we have technologies like Nginx and HA proxy and pieces that actually for the first time are providing very competitive, very aggressive TCP and HTTP performance in a small package that can be distributed out onto the application. So we're very cognizant of those platforms, some of which we're not really using most of them at the moment, but it's an opportunity to do a lot of things with those pieces.
And do you feel like this is a trend that we can kind of latch on to the conversation where people are more and more looking at, I kind of have an answer on that, but that people are more and more looking at scale out versus scale up? Or is it a combination? Or?
Yeah, no, I think that's really the trend we're seeing. And how many people here are familiar with like Kubernetes? Okay, a couple. Docker? More arms? Okay. So all you guys who just raised your arms the second time, go back and look up Kubernetes from Google. Also Mesos, pieces of this nature. What we're seeing is this ecosystem transformation, where people that started off with large instances in AWS are now subdividing their workloads, going SOA, really building out these architectures that are much more decomposable, much more compartmentalized. And it's a harder architecture to drive for, but that architecture drives us towards a more horizontally scaling architecture. And it's a very compelling piece. It's a cattle, not pets, for those of you guys who are familiar with that comparison. How many people are familiar with that? Cattle, not pets? Okay. Should I take a moment?
Sure.
Yeah, okay. So cattle, not pets, this is a very interesting concept that people have come up with. Probably, I think I heard the first time maybe 6 months ago. To be honest, I don't remember who said it.
You probably were in the same meeting that you heard it in.
Oh, really?
Was this in the down in the Bay Area with the event that was put together by Madrona? Because I think you and I met in the same place. This was the Kaiser Permanente CTO, VP of Engineering.
I don't remember. It might have been. So the philosophy behind this is that in the olden days of about 2 years ago, maybe a little bit more, the idea was that you had these machines that were specially named, right? This is database server 03, right? Or this is, Harry. You got Hermione over there, you got Ron over there, and you got all these machines are very carefully crafted to do very specific tasks. And when one of them starts having problems, you go ahead and try to fix it, right? You're having hard disk problems on that one, so you pull the hard drives out, you put new hard drives in, you try to fail over on the RAID array. It's got Ethernet card problems, you pop one out, pop a new one in. The idea is that these are pets, right? These are machines that you're carefully keeping alive, you're feeding them, you're cultivating them. This is anathema for horizontally scalable cloud applications. The modus there is really one of cattle, where when a machine gets sick, you kill it, right? And you start a new one. And because you have an application that can survive Netflix's Chaos Monkeys, that can survive outages, and is able to build up and build down based off of utilization, the fact that you killed one of them doesn't matter. You have more, and you can spin up more, and they are cattle, not pets. You don't try to recover them. You have fail correctly, NHA, and the other concepts that come there. And that's really what we're enabling as a product line, is being able to do those types of behaviors.
That's great. That's great. And then the Qumulo team, you guys are looking a lot at scale out as well. And if you guys can, maybe a little bit of the same conversation about some core technologies and maybe even how they correlate to some of the customer conversations you guys have had.
Sure. So we're building enterprise storage on top of commodity hardware. Kind of a theme that we're seeing here in commodity hardware is where the world is going. So from the technology point of view, we have to use different hard drives, different SSDs, networking, that whole variety of things on the hardware side, and make it work well. And it turns out that actually these things don't work well in general. SSDs fail, SSDs lie. They tell you when you're was the data committed? Well, it tells you it is, it was not. So that sort of stuff. So there's a lot of us digging into that, figuring out what actually happens. We actually write a lot of software that characterizes the hardware that we use to make sure that it behaves in the way that we want. As in the example of an SSD, we have this system where we actually do hard power cycles on the SSD while writing data, and then we verify that the data is correct when it comes up. It's either been committed when it told us it has, or it is not when it hasn't. And that's allowed us to find a lot of bugs in the system in different SSDs.
So you guys basically have to do call me maybe for hardware SSDs. Are you familiar with call me maybe? Oh, so how many people are here familiar with call me maybe? A couple of you guys? So there's a great series of weblog entries where a gentleman goes through and applies a whole bunch of distributed system tests against a variety of different open source distributed system databases. Cassandra, Hadoop, etcd, things like that. And he calls it call me maybe. Because you're going to call into it and it's going to call you maybe, and maybe it's not going to call you. And figuring out the reliability and the authority of those devices, it sounds very similar to that.
Yeah, and do you guys feel like the tech is pulled by the business need, or is it just that it's reached a level of scale and stuff like that?
So, yeah, I think that all of, for data storage particularly, the way I understand this problem is the reason why scale out tends to be required is no one wants to reason about data that lives in multiple different places. If I use S3, I want one bucket, I'm going to put everything in that bucket, and I'm going to keep using that bucket until I hit some limit or whatever. Like, who wants your data to be in two places? No one wants that. So scale out is sort of the, you know, if you look at something like S3, scale out of some variety is going to be the hidden technological underpinning for that. But you know, no matter what you're doing now, if your job as an infrastructure provider is to make the lives of your customers easy, having things in two places is the opposite of easy. And so everything has to scale both in performance and capacity, and that's why this is looked at through the lens of hindsight. It was a foregone conclusion that scale out would start to inherit everything because two things are much more than 2 times as complicated as one.
Also, in terms of just for infrastructure, it's for what we do. We have to solve. We kind of have to solve both the both the problems at the same time. We need to be able to scale vertical as well as scale out because for what these large customers do, if you really scale out everything, it's really hard to manage and deploy. You want to have a sort of central management, central sort of core routers, which much of this information goes, but you still need to support much of that. So we kind of have an interesting approach to this where we can scale vertically, but at the same time we can also scale out by sending data to Splunk, Elasticsearch, and there's different ways of sort of processing the data. So we're starting to see sort of this interesting marriage between both of the approaches, and and I think both will stay at least for what we're doing because it's kind of hard to you can't really change the infrastructure. You just have some of these things you just double the complexity, and you have to kind of look at a hybrid approach of this.
Yeah, if you want to give Kiran a chance to talk as well.
I want to sort of re-emphasize a couple of things that have been pointed out. If you go back 20 years ago, 25 years ago, the really cool stuff that was happening was actually in the enterprise world. I mean, the enterprise IT shop was the place where innovation was happening. That is where new things were being done. That changed around the late 1990s, and since that point onwards, real innovation, pushing the edge, has been happening in 2 places, and that's not the enterprise data centers. It's been happening in the consumer world with things like mobile first, the iPhone, all of these things. And the other place it's been happening is actually been in the hyperscale data centers, of which there are really only 5 big players. It's Google, it's Amazon, it's Facebook, it's Microsoft Azure, and it's Yahoo. That's pretty much it. These 5 together have larger scale than everyone else. And that's kind of where all the innovations are going on. But if you look at the enterprise, call it the IT market broadly, it is still a very large market. It's 10 times larger than the other spend yet. And none of the stuff's going to go away. Heck, IBM still sells the mainframes. And there is a desperate demand in that world for some of the scale, both on the consumer side of the product as well as the sort of hyperscale efficiencies that come with the large data centers within their own playgrounds. And they clearly know that's not going to come to them from their existing vendors because that's disruptive to existing vendors. And that's kind of the sort of common thread that you will see with a bunch of companies in the infrastructure space, whether it's infrastructure on-premise, whether it's infrastructure explicitly in the cloud, focused in the cloud first. That's really what you're trying to go to there. How do you help enterprises which have a much larger base than what exists elsewhere to take advantage of these 2 trends that they've been left out of completely?
Yeah, I think you really hit it on the head there. That these we call them web monsters. The really big companies that are driving a lot of this architectural change. Like the 2 products I mentioned earlier, the Docker and Kubernetes. Those were both invented at Google for all intents and purposes about 10 years ago. And those changes have been pushed out into the Linux kernel, and they're sort of been creeping out into the public awareness. But what we found is that Google figured this stuff out because they had to be web scale. They had to be web monsters from day one. And they figured this out a long time ago. And as this sort of stopped becoming a competitive advantage, these technologies, these concepts are bleeding out. And now a lot of the enterprise companies, the ones that previously were really sort of conservative and traditional and just sort of stock IT infrastructure shop, are saying, man, we want some of that agility. We want some of that ability to make rapid changes and to respond to the market. And how many of you guys have read the Phoenix Project? Anyone? Thank you. So those of you guys, assuming you actually still read books, go check out the Phoenix Project. It's a very interesting sort of DevOps story about how these types of changes can really affect compelling advantages on a given enterprise. So we're seeing these abilities, this desire within enterprise companies for the first time in really quite a while. And it's driving a tremendous amount of innovation. I mean, everyone up here, we're all targeting in one form or another large companies that are having these problems and want to have these benefits.
So we need to get to Q&A, but one last quick question before that. And by the way, for Q&A, at least I know Kiran's working with some interesting programming languages in the system and some interested distributed protocol type stuff. And anyways, I'll leave that for Q&A. But so last question before getting there, very, very briefly, what are the bottlenecks that you're seeing in technology right now? And maybe let's just go this way, starting with Bhushan.
I mean, the big thing for us is basically scaling, and basically simplifying complexity. So we want to scale to the biggest customer we have, and we also want to make that information available and actionable. So take more and show less, so that they can actually do something about it. That's a challenge for us.
I think the single biggest problem with technology is the same thing that has been, at least for the 20+ years that I have been working in technology. It's people. It's finding really smart people who can actually go grok some of these problems at scale, of scale and performance that you're talking about. That's really hard. That is fundamentally the limiting factor for changes in these areas.
Yeah, I mean, I could say IOPS or CPU or bandwidth of one type or another, but all of these problems are tractable. The people, how the customer uses it, the interfaces, the thing that we all have to remember, and this is, to be honest, enterprise development lost the thread on this for quite a few years. People have to use these products, right? You look at the user interfaces for a lot of these classic networking boxes, a lot of these classic technologies, and they're impenetrable, impossible to use. We need to take that back. We need to make it so that administrators can tackle these devices, that they can, the usability is there, that the functionality is capable, but that really, as either developers, you can write software that horizontally scales easily, or as administrators or operations people, you can use it and use it to build your organization.
So to follow up on what Kiran said earlier about enterprises being stuck in the past, the thing that I see a lot of is one of the reasons why there wasn't as much innovation in enterprises was that they were weighed down by their own legacy. Yeah. We've got 40 years of applications, or 50 years of applications out there that are part of the legacy of computation, and the innovators often get weighed down by their own innovation. So in the last decade, there have been a lot of upstarts that have a brand new problem, and they can make first principles decisions, and they come up with a fundamentally better way of doing things. Cloud is one of those things. And so what's missing is bridges to get people from the past into the future, and a lot of infrastructure entrepreneurism right now, and I think for the next 10 years, will be about building bridges to allow people to gain the benefits of a next generation platform without completely sacrificing all of the utterly gigantic legacy investment they've made in the previous generation.
We get twice the representation from.
Oh.
You could take it deeper on the tech side if you want.
Well, I was actually going to also talk a little bit about what Kiran mentioned. People, the biggest sort of bottleneck that we see is bugs, is products not doing what they're supposed to do, and how do you actually develop a product in an efficient way and deliver it right every time. So there's been a lot of innovation in the world this way, agile programming, being able to quickly iterate, really a lot of innovation on testing, how you do testing. And I think that this is where a ton of my focus is and our focus is going forward.
Great. So with that, I'd like to open it up for any questions that
Yeah, well, since that question appears to be directed at me. It's completely valid. And what you see is large enterprises build new applications either using existing methodology or new methodology. A lot of it will get built using new methodology, and as old applications become irrelevant, then they'll disappear. And there's a big part of the transition that will happen that way, doubtless. What you often see is that the most core applications to a business are the ones that have the most legacy investment around them. And so we're talking to people now about their 5 or 10-year roadmap to try and get one of these gigantic applications and move it into the cloud. These tend to be complex workflows that involve a lot of applications. The one that immediately springs to mind is modern animation companies, right, that have gigantic render farms, and they've got gigantic storage infrastructures, and they've got a complicated workflow that involves thousands of people sitting at workstations, et cetera, et cetera. How do you take one of those things and relocate it, given that you've got hundreds of thousands of applications and thousands of people that are trained, you pick up the whole thing and move it. So I think that's what I think of in my mind, but I also think you're totally right. If you've got onesie-twosie applications that don't have a ton of data gravity with other things in the company, then people are picking them up and moving them, and they enjoy great successes doing so. And they don't have to wait for their own IT department to provision a block store or whatever.
I think, sort of touching on that, what we've seen a lot in the customers that we've talked to is this problem of shadow IT. And shadow IT is roughly described as people who are very cognizant of the problems they need to solve. They're usually responsible for some part of the application, and they're just like, man, AWS solves all these problems for me. So I'm just going to go use it. I'm going to build it on my private credit card, and I'm not going to tell IT about it. And they're just going to have this application that all of a sudden works in a much shorter time period than what they were expecting. And that conflict of interest between classic IT and these shadow IT units, and trying to find some way of sort of bridging them together is really sort of an ongoing theme for a lot of these startups. Like, how do you enable developers and the people that are responsible for making the business move forward? How do you allow them to still work within the original environments and the original constraints, but not actually hinder them, not prevent them from executing?
I'd like to follow up on the whole shadow IT thing. I mean, Amazon's success is almost 100, especially Amazon. AWS's success is 100% because of what you call the shadow IT. And it's really been driven by the fact that in large enterprises in the past, IT organizations have not been seen as flexible and adaptable and listening to their end user needs. Give you a very personal example. Before starting Igneous, I was the VP of engineering at Isilon, which was acquired by EMC. I had a $12 million capital budget on an annual basis for my own IT department, effectively, my labs and so on and so forth. And I had no problems spending that money to make our engineers more productive. And I can tell you, every quarter I spent 3 hours fighting tooth and nail on every single dime of back charge that I got from the overall corporate IT group. And that is because there wasn't the perceived value. And if you talk to business owners inside organizations, you'll see that sort of theme repeating over and over again in the last decade or so. Now, folks running IT are not stupid by any stretch of imagination, and they see this. They got blindsided by this, and you're seeing a huge wave of incredible sort of attempt to listen to end users, be much more attentive to that, because their business, if you will, is under threat. So that's one of the other sort of transitions that's going on from a mindset point of view.
Yeah. You see that from bring your own device, that's just sort of an indication of it right there. Bring your own cloud.
Yeah, my first job out of college was to work for a company in South Lake Union. Before it was called South Lake Union, it was just Lake Union. And they did, it was called WRQ, and they did terminals, 5250, 3270. And I've been out of the company for 10, 11 years, but interesting enough, it's still around. I mean, the thing about, we can sit here and predict some of these things, and the outcome is not exactly what we think it is. The choices are made, and certain technology does win, and it does evolve, but it's always kind of interesting to see how that kind of plays out. The other one, kind of fast forward a little bit to now, because we have a bunch of storage people here, is Ethernet supports fiber channel. I mean, like, who would have thought Ethernet would have made it this far? I mean, like, I think last year was the first time we shipped more 10 gigabit than one single gigabit. So it's just interesting to see how some of these things evolve. evolve and sort of mature. In a ways, they do, but it's just some of these things play out very differently than we can anticipate or moving forward.
There's a question way in the back.
More of a startup question, but I'm really curious. How did you think of your startup ideas? What was the genesis of your ideas? And how did you get your co-founders to start?
I grabbed Mike very quickly on that one. Really, I mean, I've done this a bunch of times now, and I can tell you the best place to get ideas is talking to people who have problems, and talking to customers or prospective customers or users and listening very carefully to what they're saying. There is an art to that, because actually asking a customer what their problem is not very useful, because you ask them what they want, they're usually going to say the purple skies. What they really want, or a fast cars, right? So it's really being able to really live in their shoes is what's kind of the most important thing. So that's the first piece that I'll tell you, and that's always been true in pretty much all through my career. Where do you meet your co-founders? They usually are people that you know very well and you have worked with, or even if you have not worked with them, you know them very well. Because, I mean, you've probably heard this, a relationship with your co-founders, the founding team, the early team is like a marriage. You are going to spend more time with your co-founders than you are with your significant others. So you need to know them really well, respect them, such that you can get past the humps that are going to be there, as you build a company.
Yeah, I mean, sort of going in order of founding here, I think you were 7 months, right?
7 months,
yeah. So I'm about a year, 13 months now, and so we'll pass it around the rest of the way as we go through the timeline. I mean, for us, I cheated, frankly, right? We knew a bunch of people at F5. I was at F5. One of our people had come out, maybe 3 or 4 or 5 months prior. He'd taken a look around, sort of gotten a bit of the lay of the land, and then convinced the rest of us to sort of come out. And we had 5 people, all from F5 networks at one point or another in their careers. So we had this common heritage, and so that gave us sort of the template, because every long-term relationship needs some sort of common baseline, right? And from there, we were able to build out. But I think what you said about talking to customers and trying to identify the problems, go to conferences. Go to AWS reInvent, for example, and talk to everyone, and just say, hey, what sucks, right? What's the worst thing that happens to you on a day-by-day basis when dealing with AWS reInvent, right? Sorry, with dealing with AWS, or go to Azure conferences and do the same thing. And what you'll find is that there will be common threads. And it may not be as clear-cut as, oh man, I really wish T1 micros were cheaper, right? People aren't necessarily going to be that specific. T1 micros are also really cheap, but they might be all saying something like, oh, this part of networking is harder, that part of networking is harder. And this is sort of what happened to us, is that we went to this conference and we're like, oh wow, everyone's having problems with like VPNs and NACs. And how do they connect their resources? And then you extrapolate from there and you talk to more people, and you start testing your theories and building out your assessments. And this is all testing, right? It's just sort of this ongoing process of coming up with a theory, going to talk to some people. They're going to be like, no, we solved that problem really easy. And we're like, oh, okay, well, good thing we didn't do that. And then trying something different. So.
I feel like you guys have said it all, so I'll reiterate a little bit. Founder breakups are extremely destructive and painful, so work with people you know and you're pretty sure you're not going to break up with. Second, customer development is a technological disruption in the startup world. Getting serious about understanding potential customers is really important. Steve Blank says expect to spend 15 cents of every dollar you spend on building a product in understanding what the market needs. That's how you create a heat-seeking missile that by the time it's ready has a ready market for it, and it's how you end up with relationships with people such that they're going to buy your product as soon as it's ready. None of that advice, except for the founder stuff, I think applies to consumer startups, which is a little bit different. But if you're building infrastructure, I think that's the modern way, and it's how startups challenge incumbents.
Yeah. I mean, infrastructure for enterprise is especially difficult, right? Because the buy time, the lead time there is huge. And people really need to get comfortable because they're putting a lot of trust in your product because that's their jobs on the line. So.
Being last year, we knew each other at Isilon, so this is how we met, and we've worked together extensively before we started a startup. And just one more thing on figuring out what to do. hypothesis, test the hypothesis, repeat 1,000 times. Just again and again, talk to the customers. Devise a test that can get the information out of the customer that you want, and go run the test on the customers. That's
How are we doing on time?
5 minutes.
5 minutes? Okay. Wait, so what time is it specifically right now?
1 o'clock.
We'll probably run over a little bit. Let's go to that. Trent?
For those of you guys that are based out of Seattle, what kind of unique benefits and challenges does being a startup in Seattle entail? And if anyone isn't located in Seattle, why not?
You are, I mean, Seattle's an interesting city because you really have a lot of sort of having Amazon, Microsoft, Google, Facebook, and many other Bay Area companies. It's really, there's a lot of talent pool here. And it's a great city to live in, so it's really easy to attract people in here. And for being a smaller company that we are, the sort of the large companies sort of also have the black hole effect. You know, they do kind of have, I know there's a lot of people from this company. Yeah, they have a lot of draw, so it's a challenge for us to sort of differentiate and to sort of be able to attract the talent that we want. And we also wish that, you know, the college, I mean, there's only one University of Washington that really provides a lot of the students coming out, so that's also a lot of challenge for us because we want to, you know, have people that have gone to UW, but we're not big enough to be able to draw people from outside the city. So it's, you know, it's a great place to be, but it also has its set of challenges.
So before I moved to Seattle about in 2008 to work for Icebound, I actually spent all my time in Silicon Valley. I spent 18 years in Silicon Valley, a bunch of different startups out there. And the first 2 years I was in Seattle, I hated every minute of it, and I just wanted to go back as fast as I possibly could. In fact, that was my first thought when EMC came along to buy Icebound. Turns out, fast forward a few years, and when it was time to start Igneous, I had the option of either doing it here in Seattle or doing it in the Bay Area. And it was not even a question that we would do this in Seattle. There's a couple of different reasons why. One, Madrona as a company and as a venture firm is incredibly grounded in Seattle, incredibly helpful. And while there are plenty of, you know, VC firms in the Valley, all of whom are very big and very well known, there is a level. An early stage startup is a high touch relationship with your investors, and I felt that we would get that far better with Madrona than any other large company. The second thing is Seattle is today, and I've said this many times, more like what the Bay Area was, say 20 years ago. Yeah. It is on the cusp of takeoff. If you look 10 years, 12 years ago, it was really a Boeing and then a Microsoft town. Now there is a profusion, there's absolutely a proliferation of startup activity. There's been a lot of really good exits, you know, between Isilon, there was F5, there's been Tableau, there's been Zillow, there will be Redfin. So it is a very vibrant place. I think you're about 2 or 3 large exits away from making this literally second to none, not even Silicon Valley.
Yeah, I think that really hits it. I mean, there's a lot of really great things about Seattle. And to be fair, and Shadow, what you said on that, Madrona's been absolutely awesome for us. The community up here is incredibly vibrant. We are up here, the cloud center of the planet, right? We have every single cloud, literally, and if, you know, we don't. Right? They have an office up here, like, I mean, even down to like the low tier ones, right? Like, you know, anyone from HP here? No, good. Okay, so even HP cloud is up here, right? You know, and this is where the talent is for that type of environment. So as a cloud company, it's fabulous, right? Because, you know, we have those other, you know, pools to pull from. We have those other talent centers to help draw talent up here. And I think, you know, I hear this from a lot of people. You know, this is the Silicon Valley, the Bay Area 10, 20 years ago, right? And, you know, we've even got our own peninsula to grow up into. So that's a really powerful thing. I will say on the negative side, we're still very young as far as the VC infrastructure up here. So while Madrona is a fabulous company, and I haven't regretted for a second getting money from them and working with that professional relationship, the follow-on fundraising thing is a little bit complicated. So you have to go down to the Bay Area, and the truth of the matter is, Bay Area VCs, very, very few of them understand cloud. You know? And and that's something that we've run into a couple of times.
I guess different perspective for why Seattle's fundamentally great. I see companies as being like ropes. Ropes are made up of many strands. Or companies, the strands of people's lives, right? When you want to build something successful, you're bringing together a group of people who create this rope effectively. You can't build a rope out of strands that are half an inch long, right? The rope will fall apart immediately. I have a hypothesis, I haven't tested it or proven it, that we have much longer tenure in positions here in Seattle than in other places where there are lots of startups. It's hard to build something big, long-term, and strong out of individual things that are not in it for the long term. So the thing that people complain about over and over again about the Valley particularly is extremely short employee tenure as people hunt around for what the next big thing is going to be.
3 years, yeah.
So it's a cool thing about Seattle. I think that it's one of the unsung factors in our success in building a disproportionate number of extremely successful companies.
Yeah,
And I have no proof of that, so I invite Madrona today to conduct some research on this topic, or maybe myself. I should stop being lazy.
All right, last question. It has to be super technical. We can talk about entrepreneurship later. Okay, super technical question.
Programming languages. You said somebody using cool programming languages. What are
How
you
many
doing?
people from Google here? Well, so we have chosen to use, to build our system, which is highly distributed across multiple platform stacks using Go. It was an interesting choice for us to make about 6 to 9 months ago. It's worked out very well. And if you're familiar with Go, awesome, you should come and talk to us.
Yeah, I mean, I would actually second Go. We're not using it internally yet ourselves, but we're looking at it strongly. Right now we have a Python, C, C++, Lua stack. And so you can sort of figure out where some of those languages lie in our architecture, depending on how you use them.
The vast majority of our product is written in C, but it's kind of our own dialect. So we wanted to do containers, so we have a bunch of auto-gen code that makes containers. We basically build things in when we need them and have nothing that we don't need. It's basically, so we didn't start with C++, we started lower level, but sort of built the things that we needed. And that's actually a big part of our culture is just doing what you need to make it, to make what you're trying to build look clean and efficient and good.
So you hack the compiler, or you're just using code gen?
We're using code gen. We also hack the compiler for little things. So we have our own format called, like a printf. Instead of, we have a different percent thing that has the compiler checks that properly if the args are right and things like that allow us to debug that properly. We use a lot of the features of GCC that's not standard C. Warn unused result, which is an attribute, is super useful because we never leak any return values, any errors or anything, because the compiler enforces that it's always checked and things like that. And static analysis, we really love anything that we can do along those lines.
So GCC.
It's actually Clang, but
okay, because we use Clang as well. So yeah.
But Clang has all the GCC.
Yeah, I mean, we have an interesting mix. I mean, obviously the high performance part of the system is in C, but it is not necessarily growing as fast as Go. I mean, so almost raised their hand. Go is actually something we're adopting more and more. In fact, it's probably taking place of what was traditional Python. So the two areas that's actually really growing for us is JavaScript and Go.
Cool. All right, are you guys able to stick around? Yeah, so I mean, if you guys have additional questions, you're welcome to.
Just, you said JavaScript. I'm assuming that means you use codes for your data transit on the back end, or JavaScript?
That's a longer answer, but the visualization, all of our visualization is actually in JavaScript and HTML. But we also have we've embedded basically an interpreter, so customers that actually write customizations, even at the packet path, is actually written in JavaScript. So you can actually, our customers write JavaScript code to customize the system. So we've actually embedded it in there.
Yeah, so thank you guys for being here. Really appreciate it. enjoyed this. I will bug you a little bit for a survey, because that's what will allow us to keep doing these things. If we get feedback from you guys and it looks like it's useful to you guys and you want us to keep doing this kind of thing. But that's it. Thanks again. You're welcome to stick around. I think there's a little food left, and feel free to grab these guys and have a conversation. So thanks, guys.